Okay, nuclear chemistry.
Yes.
Okay, swag. So, alpha decay. Flip my camera around so you can hear me. Ooh, that didn't work. Okay. Alpha decay. Alpha looks like this.
I look forward to
Oh,
going
yeah.
to school every day in order to learn new ideas. Depends.
I put a 2 on that.
I'm putting a 4 on that because I learn some new stupid shit every day.
Okay. So there is not a symbol for decay.
Wait, but it's
It's
not
we just do an alpha.
Jesus fish.
Okay.
But quirky.
Quirky Jesus fish. Yeah, sure. So alpha alpha decay is when a nucleus radiates out a proton. So 2 protons actually. So what happens is the nucleus, that's supposed to be whatever, shoots out two protons, 2p plus, and 2 neutrons.
Yeah, this reminds me of that meme I showed you. I feel like this type of decay seems very exciting.
This type of decay is the weakest kind of decay. We'll look at that in just a minute. So this, the 2 protons and 2 neutrons, is called an alpha particle. 2 alpha, well, that is supposed to be an alpha, but it is not. Let's try this one more time, shall we? Yeah, close enough. Okay, an alpha particle. Yikes. All right. An alpha particle is also just a helium atom. 2 protons, 2 neutrons. Okay? So what happens is the atom shoots out 2 protons and 2 neutrons, also called an alpha particle. So for instance, let's look at the example of titanium. And when we write this down, we're going to write down titanium. We're going to write down its mass, which is 48. And its atomic number, which is 22. Like that. Okay? Titanium, 48. 48 meaning its mass, right? It's isotope. If it undergoes alpha decay, what will happen to it? Okay? You don't need to answer this yet. We'll do practice problems in a little bit. If it undergoes alpha decay, it goes from being titanium.
It goes down, well, it loses 2 protons and 2 protons and 2 neutrons.
Right, so it loses 2 protons, 2 neutrons.
It loses 2 of each, and then it goes down.
Meaning, yes, it becomes calcium, which has an atomic number of 20, and its mass will become what? If it's 48, what will the mass become? 44. Do you see why it went from 48 to 44?
Yeah.
Wilkes?
It's kind of like some like atoms, especially in the air, the one time like they don't live long or can.
Yes, they don't live very long because they are unstable. The nucleus is unstable. So the farther down you go in the periodic table, the less stable the nucleus becomes. This is because the interactions between the protons Protons are all positively charged. They don't want to be by each other. They're held together by the strong nuclear force. But the strong nuclear force can only hold it together for so long.
So there's only so many, like, as we keep creating these dummy materials, there's only so far we can go before, like, there's just too many protons.
Well, we've already reached that limit.
Oh, we already.
All of the elements on the periodic table that are just outlined in white only exist for seconds, and then they decay radioactively.
I mean, I know those ones decay, but is there a point, like, where, like, it's just so unstable that we, like, won't even be able to form it? Like,
Well, it will form for fractions of a second, and then it will just fall apart. Okay, so that's alpha decay. The next one is beta decay.
hey, it's midnight, boys.
Oh shoot, that's beat.
Yeah. Honestly, I'm used to it. Everybody hates me.
And that's not like Donkey Kong.
I actually do play Donkey Kong next to Side.
Okay, but
Okay, so beta, that's a beta letter, okay? Second letter of the Greek alphabet. A beta decay is interesting. Beta decay, a neutron turns into a proton. A neutron turns into a proton. And the way that happens is an electron is shot out. Pew! Okay? So the neutron becomes a proton, and an electron is shot out. That electron is called a beta particle.
electrons are wrong. Electrons are lame. Let's get rid of them.
Just get rid of it.
Cancel culture comes for electrons. What do you do with that?
Okay. So beta radiation is an electron that is shot out by a neutron, as that neutron becomes a proton. What? But you didn't know that protons can become neutrons and vice versa.
Wow, I had no idea, Mr. Croshaw.
Thanks, Felix.
I actually had no idea. I had no idea.
Oh, we haven't even talked about positrons yet.
No. I know very
That sounds
much.
like a transformer.
Not a positron.
Positron. Positron, roll out. What? So, yes and no. Schrodinger.
The
Schrodinger's.
last unicorn, that's the only way I can explain it.
Yeah, so that's an excellent question from Wilkes Jr. Do all neutrons consist of a proton and an electron together? Kind of, but not really. Okay. Protons have 2 up quarks and 1 down quark.
Oh, quarks and stuff.
And neutrons have 2 down quarks and 1 up quark. What happens in this, and this gets into quantum stuff that I do not understand. What happens with this is that one of the down quarks flips to become an up quark. And when that happens, energy is released in the form of an electron. Yeah, I don't know either, okay? I don't. No, trust me, guys, we haven't even gotten into like strong nuclear force, weak nuclear force, antimatter, like.
For those at home, please do not be discouraged.
Go into quantum physics.
Okay.
If we had poured antimatter into the Chernobyl thing, like, would it have prevented the meltdown?
Yes and no. It would have prevented the meltdown, but it also would have converted that whole area into pure energy.
Oh, so you're saying it would have been worse?
Yes. When antimatter touches matter, they annihilate in a reaction that creates pure photon energy.
So you're
Why don't
saying,
we have reactor?
We hypothetically could in the future. Making antimatter is very difficult.
so you're saying,
Okay, but like also if
so if we poured massive quantities
Quantum physics, theoretical physics. Theoretical physics. Okay, so that's beta decay. Let's talk about gamma really quick. You may recall this as the source of the Hawk's power.
oh yeah, no.
The way that you write gamma is like this. So it's kind of like that. It's a weird. It's kind of like a Y, but not. I don't know. Yeah, the base of it's supposed to be longer. Anyway, I don't care. Gamma radiation is when a nucleus. Let's say that this is the nucleus. It's all bumpy because it's got all these protons and neutrons in it, right? And it's definitely not circular. I don't care. It is excited. Because what has happened is some energy came in and gave some of its electrons some extra oomph. And then when it becomes less excited, this is the big sad nucleus. Big sad. It sends out a gamma wave, which is just like light, just really high energy light. It's light that will go straight through you and completely destroy your DNA and kill you. This is gamma radiation is the dangerous stuff. This is the stuff that causes, radiation poisoning.
So you're telling me that the Hulk is constantly in agony?
Yeah. If you actually got irradiated with gamma rays like the Hulk was, you'd be dead within a few hours.
Nah.
Because all of your cells would just die.
what if I ate the entire jar of this whole moments before I ate
Still death.
I think you would die faster.
No, I think at this point,
Okay. Transcend the mortal realm. Okay. So just as a review, let's look at this. We're going to check out this image, this infographic of the three. Okay, three basic types, alpha, beta, gamma. Okay. Alpha, beta, gamma. We haven't done a beta example yet, so let's do one of those. Okay. So alpha, beta, gamma. Alpha, remember, sends out an alpha particle, which is just a helium nucleus. So the nucleus loses 2 protons and 2 neutrons. It loses 2 from its atomic number and 4 from its atomic mass. Right? Okay. In beta decay, we have a neutron becoming a proton. Neutron becomes a proton. and it shoots out an electron, a beta particle. A beta particle, which can be written like this. It can be written as an E, indicating electron. This is it has a mass of 0 and not a charge, but an atomic number, quote unquote, an atomic number of -1. Okay, so let's do a beta particle or beta decay reaction. All right, let's do a beta particle. Gosh dang it, a beta decay example. There we go. All right, we have palladium, and palladium undergoes beta decay. What will happen? So first of all, palladium has the atomic number of 46, and let's say that this atom that we're looking at has a mass of 107. Okay, 107. So what is going to happen to this palladium after it undergoes beta decay? A neutron becomes a proton and emits an electron.
So mass isn't going to do much, right?
Mass is not going to change, exactly. Jack has hit that on the head. The mass is,
electrons are little babies.
yeah.
It's gonna go to 45. Yeah.
It's not going to go to 45 because a neutron is becoming a proton. We are increasing the atomic number by 1. So we go to 47. So we have made silver out of palladium. Palladium, this is not a good business model. Palladium is actually way more valuable than silver.
I love it. Switch it then.
Well, what we could do, what we could do is we could make the silver undergo beta decay again, and then do alpha decay back to palladium.
This is sounding like some Nile mess.
Well, what does silver turn into after that? What's CB?
Cadmium?
How expensive is that?
Cadmium is meh.
Okay, let's just buy that.
You know, this is starting.
So we buy some cadmium and make it undergo alpha decay so it becomes palladium.
Yeah.
There you go.
This is starting to sound like Nile. Like.
Okay. So alpha decay, you lose 2 protons, 2 neutrons. So your atomic number goes down by 2. Your mass number goes down by 4. Beta decay, a neutron becomes a proton, so your atomic number goes up by 1 and your mass does not change. Gamma decay, we don't need to talk about that too much. Gamma decay, nothing really happens. It just goes from an excited state to a not excited state and releases a gamma.
As part of the review, can we watch the Nile video where it turns plastic lugs into good soda?
No.
Please.
Okay. Questions about alpha decay, beta decay, or gamma decay, or gamma radiation?
Why doesn't it ever go up beta?
Because a proton is made out of a neutron. Remember that the atomic number is the number of protons. If we have palladium, if we have palladium, it's number 46. If it undergoes beta decay, its atomic number will go up to 47 because it gains a proton because one of its neutrons has changed into a proton. Okay? All right.
I'm curious how much the equipment would be to turn the cadmium into palladium and just like.
Probably quite a bit. Okay.
So I wonder how much like palladium.
So let's finish the video there. Yeah, and then we're gonna do some practice examples.